Hello dear students, welcome back to a new lesson of chemistry for grade 10. Today we'll study the electron configuration and periodic properties. We will study how some properties will differ when you move across the period and across the group. First we will discuss the atomic and ionic radii and the ionization energy and compare the periodic trend of atomic radii, ionization energy. Compare the trends of atomic radii means see how they vary when you move across the period or across the group, and make a comparison between different elements down the group or across the period. First of all, let's study what we call the atomic radii, and radii is the plural of radius. What is the atomic radius? Actually, you can't measure accurately the atomic radius because, as Heisenberg stated, that it's impossible to know the position and the speed of the electron at the same time because the electron is moving with a very high speed. So if you want to measure the atomic radius, you have to measure the distance between the center of the atom, which is the nucleus, and the last electron or the electron in the last energy level. And since the electron is moving with very high speed, so you can't measure the atomic radius accurately. So what to do? We will get two identical atoms. Two identical atoms means two atoms of the same element, and measure the distance between the two centers, which are the two nuclei of the two atoms. Then divide this distance, divide 2, you will get the radius of each atom. Meaning, if you have here, look at here, the atomic radius of hydrogen, we have two hydrogen atoms. To measure the atomic radius, you must know the distance between the center, which is the nucleus, and the last energy level, or the electron in the last energy level. This is the atomic radius, and since you can't measure it accurately, you get a molecule of hydrogen, which is two hydrogen atoms joined together, and measure the distance between here, the center of this atom, and the center of the other atom. Then divide this distance, divide 2, you will get the radius of each atom. So you get the atomic radius and know how they measure the atomic radius. Two identical atoms, two atoms of the same element, measure the distance between the two nuclei, then divide this distance, divide 2. Now we back to the periodic table and want to see what happens to the atomic radius across the period and across the group. Look with me at this periodic table. You will see that when you move down the group, started from here to down, what changes during movement in the group? There are more energy levels. More energy levels meaning here hydrogen has only one energy level. Lithium in period 2, so it has 2 energy levels. Sodium in period 3, 3 energy levels. Potassium in period 4, 4 energy levels, and so on. So when you move down the group, you notice that the number of energy levels increase, and since the number of energy levels increase, this means the size of the atom increase. So when you move down the group, you will notice that as you move down, the atom becomes bigger. So cesium is bigger than rubidium, rubidium bigger than potassium, potassium bigger than sodium, and so on. So what happens to the atomic radii when you move down? The atomic radii decreases across the group. And what about the atomic radii across the period? Here when you move across the period, you have the same number of energy levels. So what the difference? The difference is the number of protons, or the atomic number. As you move from left to right, the atomic number increases. So this means that the number of protons also increases because the atomic number is the number of protons. So what? So as the number of protons which are inside the nucleus having positive charge increases, this increases the attraction force to the last electron in the last energy level, or the electrons in the last energy level. So when the attraction force increase, of course the size of the atom will decrease. Imagine you are moving in a circle, you are making a circle and there is someone in the center and trying to attract you towards it to the center. You will notice that your circle will become smaller. That's exactly the same here. When you move across the period from left to right, the number of protons increase. So when the number of protons increases, so the attraction force of them increase, making the atom smaller. So now we see that across the group the atomic radii increase. Why? Yes, because the number of energy levels increases, but across the period from left to right the atomic radii decrease. Why? Because the attraction force of the electron increases, that makes the atom much smaller. So look here, when compare chlorine to aluminium, aluminium is bigger than chlorine. When you move from left to right, as you moving to the right, the size becomes smaller. So chlorine is smaller than aluminum, or aluminum is bigger than chlorine, the same. Back to our slides here. Atoms tend to be smaller, as we said, the further to the right they are found across a period. So across a period, you have across a period, it becomes what? It becomes smaller. The trend to smaller atoms across the period is caused by the increasing positive charge of the nucleus. As we said, the positive charge are the number of protons, which attracts electrons toward the nucleus. But atoms tend to be larger the further down in a group. Why? Because the increasing size of the electron cloud, meaning more energy levels around the atom, and the number of electron sublevels increases. Electron levels and electron sublevels. To summarize this, you see here in the atomic radius, down the group increases while it is decreases across the period. Here the cation and anion, will discuss it later on. So this is a question. Of the elements magnesium, chlorine, sodium and phosphorus, which has the largest atomic radius? And explain your answer. So we have magnesium, chlorine, sodium and phosphorus. Back to the periodic table. Magnesium, chlorine, aluminum, phosphorus and sodium, of course. Now, as you see, they all found in the third period. All the elements listed in the question are found in the third period. So which is the smaller and which is bigger? As we said, as we go in the same period from left to right, the atomic radii or the atomic size decrease. So chlorine will have the smallest size, while sodium here in the beginning will have the larger size. So the question states that which has the largest atomic radius. Of course, sodium will have the largest atomic radius because it's found on the left side. Here sodium has, this is the answer to the question, sodium has the largest atomic radius because all the elements are in the third period. So when you go across the period, the ones on the left will have the larger size. As we go from left to right, the size becomes smaller. This is for the atomic radius. Another property or another trend is the ionization energy, and we'll see also how the ionization energy changes when you go down the group or moving from left to right across the period. What's first the ionization energy? Ionization energy, as you see, it's begin with the word ion. Ion, what is the meaning of ion? The ion is any atom that lose or gain electron. It's not a neutral atom. Now the number of electrons changed, so it may be positive or negative ion. It will become positive ion when the atom loses electrons, because here the number of protons will become bigger than the electrons, so it will have more positive charge than the negative ones. And the negative ion is produced when the atom gain electron, because when the atom gain electron, it add more negative charge, so the negative will become more than the positive charge, so it will have a negative charge as a whole, so it's an negative ion. So now we have ion means atom that gain or lose electrons. What's the ionization energy? The ionization energy is the energy needed to remove electron from the atom, the energy needed to make the atom lose electrons. So imagine that you have sodium and chlorine, and imagine which of them will lose the electron easily. Of course, someone will say that sodium will lose the electron easily. That's right, but why? Because sodium is a metal and chlorine is a non-metal, and we all know that all the metals tend to lose electrons during the chemical reaction, while the non-metals tend to gain electrons during the chemical reaction. So as the element is a metal, it's easily to lose electron, but as it is a non-metal, its ionization energy, or the energy needed to remove the electron, will be bigger. So low ionization energy means the atom lose electron easily, while high ionization energy mean you need high energy to remove the electron. It's difficult to remove the electron, so it is mostly non-metal. So what is the graduation of the ionization energy inside the periodic table, down the group and across the period? Look here. When you see this first group or any group from up to down, we say that from up to down the size will increase. When the size increase and the atom becomes bigger, so it will lose electron easily. Why? Because the electron will be lost from the last energy level, and as the atom becomes bigger, so this electron in the last energy level will become far away from the nucleus, far away from the attraction force, so it can be lost easily. So as the size increases, the ionization energy decrease. Ionization energy decrease means the atom can lose electron easily. On the contrary, when you move from left to right in the period, as we said that from left to right the size decrease. Size decrease meaning the atom becomes smaller. Become smaller means that the electron in the last level becomes nearer to the protons, or nearer to the attraction force. So the protons are tightly holding the electrons, tightly attracted the electrons. So to remove the electron you need more and more energy, because it's difficult to remove electron from the atom. So when you move from left to right in the period, the atomic size decreases, the size becomes smaller, so it's difficult to lose the electron, so you need more and more energy, which is called the ionization energy. So what is the ionization energy? The energy required to remove one electron from neutral atom of an element is the ionization energy. Now I want you to think, if you have a metal and you lose one electron, if you lose one electron, so the attraction force of the nucleus will be larger and larger for the rest of the electrons. So to remove another one, you will need more energy. You lost the second electron and now you want to remove the third electron, so you have to exert more and more energy. So take care, the first ionization energy is the ionization energy to remove the first electron will be less than the second ionization, the third ionization, and so on. As you remove more and more electrons from the same atom, you will need more and more energy. Now here is a diagram that shows the graduation of the ionization energy. As you see here, in the first period started from hydrogen and helium. Hydrogen has low ionization energy and helium has high ionization energy. Here in the second period, starting from lithium to neon, you will see that neon also will have the largest ionization energy. And when you move to all the periods you have till period 7, you will notice that the noble gas will have the higher or the highest ionization energy. Why? Because the inert gases are stable. They are stable enough. They don't want to gain or lose any electrons. They are stable. So if you try to break this stability of the inert gas, you will need more energy, more than you can expect, because you will break the stability of this inert gas. So inert gas has the highest ionization energy ever. And here, as we said, the periodic table, you know now down the group the size increase, so the ionization energy will be smaller because it's easy to remove the electron. But in the period, as you go from left to right, the size becomes smaller, so it's more difficult to remove an electron from the atom, so the ionization energy will be larger. Now look at this question. Consider two main group elements, A and B. Element A has a first ionization energy 419 kilojoule per mole. Element B has a first ionization energy of 1000 kilojoule per mole. So element A has lower ionization energy, meaning it can lose electron easily. But as you noticed, element B has higher ionization energy, so it needs more energy to remove the electron, meaning it's difficult to remove the electron from it. Now the question is, decide if each element is more likely to be in the S or P block. Now we know that S block contains metals. They are the first and second groups, while the P block contains the non-metals, which are on the left side of the periodic table. So which of them will be in the S block, meaning which of them is metal, and which of them in the P block, meaning which of them is a non-metal. Now in the S block it's metal, so it will lose the electron easily, so it will have low ionization energy. But the one with the higher ionization energy means it's difficult to remove the electron, so it's in the P block. So A is in S block and B is in P block. And which is most likely to form positive ion? Of course, the metal, which is element A, will form a positive ion, because it will lose electron easily. All the metals lose electron, forming the positive ion. This is the solution. Now element has very low ionization energy, which means that its atom lose electron easily, and it's likely to be in S block, because metals are found in the S block. They have low ionization energies. But B has very high ionization energy, which means it's difficult to lose electrons, so it's mostly like found in the P block. And the P, of course, will make a negative ion, not a positive ion. I think the lesson is easy. Try to practice and solve more questions on your classwork and homework that are uploaded on the school site. I'm with you for any question. Till we meet again, goodbye, dear students. Study hard, be safe, and bye.